Won't slow down. Welcome everybody to another DoneJS contributor meeting. I am back, baby, and I'm roaring to go. With me is a few of our noble contributors. Christopher, you want to say hello?
Hi, Christopher from Reno.
Hi, I'm Kevin from Downers Grove, Illinois.
Matthew, Kentucky.
And I am Justin from Chicago. Welcome. Thank you for joining us. A lot has happened. Did we do the contributor meeting last week after 4.0? Or is 4.0? Have we talked about 4.0 being out at one of these?
Yeah.
Yeah, we did. Okay.
It was out, but not officially.
Did I make them? I don't remember if I made the last one. It's been a hectic few weeks for me. But CanJS, well, it bears repeating. CanJS 4.0 is out. Please check it out. I'll put a comment in YouTube or whatever if you're watching it. But Toby has a blog article where I go into exquisite detail on almost every little bit that we did. Actually, not even close to what we did. Just some of the best parts of what we did. There's a million little subtle improvements. And then here's Manuel. Manuel, you want to say hi? You're muted, Manuel. But he says hi.
Okay, sorry I'm late. Hey.
No problem. Welcome. All right. So, Christopher, let's do demos. Do you want to go first?
Sure.
Christopher, despite his lack of enthusiasm, has been working on Can Observe, which is one of the juicier bits of 4.0.
Yes, though I was going to show the real quick. One of the things I did this week was use Prism to highlight our docs. So very soon, your text snippets in our docs should be much nicer to use with a couple extra features in them. But as Justin was saying, Can Observe. So one of the first things we did was, oh, wrong one. We added rich property behaviors to Can Observe. So the way they, basically it just allows you to sort of add arbitrary advanced logic through a relatively simple mechanism. So you can, and we made it very easy to create your own. So in this case, we've created an observation that pulls the first and last and joins them on a space, so like your name. And then it exposes it on the name property. So if you have an instance of the object that this was added to, it basically has a smart getter or an observed getter. The particular example is very boring, but the functionality is very powerful. One of the other sort of goals we wanted was to be able to do this with decorators. Sorry. So there is the exact same mechanism for adding that you can do with decorators. So in this case, I've created a decorate option, which just takes that first and last on the inside and then uses the decorator to add it to the property definition instead. The docs will be released very soon for more technical details. There's quite a bit in here about how this actually works.
Cool. Whoa, dog. So a few comments about that. Like, can you keep it up, Christopher? Can you keep sharing your screen? Once the dog allows you to. I think he was really excited, or she, about it. And I guess I don't want to be like, I don't want to put it might have been a cat barking like that. I don't want to prejudge what kind of animal you've got there.
No, that was
I'm woke like that. So the I see Kevin and Matthew rolling their eyes at that. So the cool thing about this, I think, is that which will eventually be part of the documentation, is you don't necessarily need to return to observation. If you want to add special property behaviors, you just need to return on like line 347 something that implements can reflects get value, set value, on value, off value, and you can make it, as long as you return something there, it's essentially installing that into the observable can observe. So that thing will be read and written to instead when the property is read and written to, and that thing will be bound to when on and off is used on that observe. So it's a pretty kind of, I don't know. It's nice that we have this interface now that you can add whatever behavior you want. So hopefully other people in the community will start adding these rich behaviors because we're focusing on making it so easy, where these things are kind of locked down inside can define. We're trying to bring them to the forefront in can observe.
And I actually forgot to mention that there are 2 decorators that come shipped with can observe. The first one is async. Sorry, still updating docs. The first one is async. So if you attach it to a method, then it gives you a resolve function, which you can call with whatever information you're looking for. And you can call that as many times as you need if there's some sort of interval or something. And then if you attach it to a getter, that will allow you to return a promise. And the promise's resolved value will be what's returned for that value. And then there is a resolver decorator, which is based on can simple observable / resolver. What that does is it gives you a resolve very similar to the async, and it gives you a listen to. So in this case, what this example here is doing is every time the base value that's on like the this dot value changes, it increments the count accordingly. So you can add all kinds of complicated logic with the listen to and the resolve to get almost any functionality you're trying to create there.
Awesome. Yeah. Pretty excited about that. For the next demo, Matthew, you want to go next?
Yes, I would love to. Okay, so I added a can route stop this last week, and can route. Where's my docs? I had those here. Oh, where are they? Yeah, this has it. So this is in can route 4.1, but it hasn't. We haven't released a CanJS 4.1. So if you go to the canjs.com, you won't see the docs there yet. Again, when we release a 4.1, it will show up then. Can route stop is the opposite of can route start. Use can route start once you've registered all of your routes and you want the URL to get updated to, or you want the URL in your data to get updated to reflect what's in the URL and what's in your data. Stop is the opposite. It unbinds your observable from the URL, so it will no longer update the URL once you actually make changes to your observable. So this is kind of it's a weird one. There's not like a ton of reason for users to use this, I don't think, but people do weird stuff, so maybe they will. We do use this in DoneJS though. The user, I believe his name is Greg. I don't want to mispronounce his last name, but he is a frequent DoneJS. He makes a lot of issues, which is awesome.
Looks like an adventurer as well.
He does look like an adventurer. Not me. He is braver than I am. Anyways, he was using can route data in like a view model. So he was just returning route.data, and then he was binding that to another component so that component could actually change like a property on can route data, and that would hopefully update can route data and update the URL. But it doesn't update the URL was the bug. And the reason why is that it does. I'm sorry, back up a second. It does, it works great, except when live reload occurs, because live reload creates a new view model. So every time live reload occurs, it creates a new instance of your application view model, and it sets route.data to be that instance. So this actually changes. And the good thing is like kind of within this component's view model, it does reflect that the route.data has changed, which is nice. But this stops working because route.data is no longer bound to the URL. The new one is not. And this is because in live reload, we don't tear down we don't call there was no can route stop. So we just created a new view model called start, but it was still being bound to that old view model, which is no longer, used in the application. So yeah, I created can route stop. So now live reload will call stop. And then when the new view model is created, can route data will now be bound, or excuse me, the URL will now be bound to that new view model, which fixes the bug. So yeah, we have a can route stop now.
Nice, well done. Kevin.
Yep, I will go next. So this week I've been working primarily on a new guide for how to work with forms. Before I get into that, I'm going to show a bug that I ran into when I was creating one of the examples for the guide. So this code is kind of similar to what Christopher was showing with the new resolver observable. So what this is supposed to do is basically when the user types an odd number, it will update this odd number property to be an odd number. If the number is even, then it will not update, right? So it's listening for changes on when this odd number property is set, and then it actually only resolves if it's an odd number. So the bug that I ran into was that it didn't work. So if you type an even number, you can see here that for whatever reason, this is still being updated to this even number. The thing that was really confusing about this is that if you take a look, I've got can view model here on the window. If you take a look at the view model, oops, what is that thing? Odd number is actually still an odd number. So it's very confusing that we're seeing these even numbers in the page. So one thing we looked at to debug this was we turned queues logging on. And if we make the same change now, we get all of these different things that happen. Just a little bit smaller. And going through all of these, the one that's interesting is this one that says my comps VM's odd number changed to 4 from 5. So the next thing that I would do if I were debugging this again is
Kevin, if you're typing and talking, you've been automatically muted and we haven't heard what you've said for the last 5 seconds.
Yeah, I wasn't talking. My mechanical keyboard. Yeah, it's fun. So yeah, if I do this again and change this to another even number, we see that this debugger hits. So there is an event that's being triggered for this one. And what's interesting is if we change it to an odd number, there should be 2 events that are happening. So that's basically the 2 things that I wanted to show. 2 techniques for debugging this are turn on queues logging and then listen for events. So we eventually tracked this down, and what was happening is for this value or this resolver observable, it was setting up a type converter for this. And so there was one change event that's happening through the type converter and a second one that's happening when this resolve actually happens. So the fix was just to get rid of that type converter.
Kevin, what would happen if you in your console you did VM $? Wait, you can't do canned view model, right? Where's this VM helper coming from?
This VM is can view model. I'm not using the global can.
You're not using the can debug. Okay, so I would say if you the super pros would have can debug conditionally loaded in their CanJS 4.0 application. So you can always just run can.viewModel to get a view model.
Mm-hmm.
And then 2, I think you could do just log on define maps now and just log and say that property, and you'll get that nice kind of output. You won't get a debugger, but you would also be able to see that, say log odd number. And then if you changed it, it should give you the same thing.
I still have my debugger.
It gives you it nicely printed out.
I'll try it again because it was confusing.
Now, as he changes it, you can see the odd number printed out. My comp VM, the key odd number changed was 5.
Cool.
How did you do that? Oh, with the log. Okay.
Cool.
Manuel added it.
Awesome.
Nice.
Awesome. Cool. So that's all I wanted to show with that. This is fixed now and released.
Awesome.
Cool. So the other thing that I wanted to show is a quick preview of the forms guide that I've been working on. This is my my Moby Dick of guides. It's going to be like 1,000 pages long. But anyway, so I want to give a quick preview of this in case people have ideas for ways this could be set up better or something. So basically, the approach that I'm taking is, first thing I want to show is just like a bunch of examples for all of the different form elements. And then after that, some advanced topics, and then some like appendices stuff. So if we scroll through this, you can see it starts off with text fields, gives a little bit of background, shows a demo of one-way binding, another demo, one-way, only one-way, etc. And explains event bindings, explains, what's this one? Listening to a different event, input events, shorthand stuff, which is cool. And then two-way bindings. It goes through all of kind of the different permutations of bindings for text fields, since it's the first one. And then it goes on to checkboxes, and there's not as much to explain because the differences between this and text fields aren't really all that different. It just shows kind of some of the nicer things. This is using the Boolean to in list converter, which is cool. And that's basically how this is set up. So there's going to be like 1,000 examples on this page for each of the different form elements, and all of it kind of builds on the text field. So what I was kind of what I've gone back and forth on is, really, should I just move this initial stuff into like a separate section about bindings before talking about text fields? Because really, like, if you come into this and you want to learn about, you know, numbers or whatever, you really have to read the text field one in order to understand. So
I think it's fine to do an overview first.
And just use, yeah, okay. That's kind of what I'm
saying. Like, you should make sure you read this overview before you go to any of the other sections.
Yeah, that's kind of what I was thinking too, because otherwise you have to read through the text field one, which is, I don't really want people to have to do, because it really is nice to be able to jump to exactly the thing that you're working on and just kind of use this as a reference.
And you're showing converters in this? Yeah,
so that, so yeah, this is using the converter for this one. It's going to use either or. I'm going to show the different converters in the places where they're useful with those examples. Cool. So that's a preview that should be out sometime early next week, hopefully.
Awesome. Looking forward to it. All right. Anything else anybody wants to talk about? Then I'm gonna do mine. So I've been brainstorming about how can set and can connect should work, and boy, has it been rough. Very difficult, challenging problem. And I'm just gonna open up the discussion kind of with where I'm at right now, and kind of talk about where I'm going and just see what people think. And my goal right now is really just to solve can set and not really do can connect, but you can't, they're so related. I have to be thinking about can connect while I'm doing improving can set. But let's just, let me just walk through this comment here, which is like my last comment on this. Okay. So the first thing is, I think you have to recognize when considering how to make what I would like to make, which is a perfect model layer or a very awesome model layer, is the problems that we are trying to solve. And I would say that there's 2 or 3 main things that I'm trying to solve, or at least I think I really want to solve. The first is just providing a standard interface for creating, deleting, updating, that kind of thing, making that stuff easy to the server. A standard interface, to me, that's actually not even, like, that's useful, but like you could always just do fetch and, you know, avoid, use fetch yourself. What I actually really think now, what can, well, the next thing that's kind of subtle too is that it provides kind of conventions around how your data should look. In some ways, it's satisfying what JSON API does or something like GraphQL. It's just saying, like, here's probably how your request should look, and make a standard way that works well with CanJS. That's also useful. But one of the really powerful things that I think it can do, and this is where CanQuery comes in, or CanSet comes in, is it can handle automatically keeping your data looking right as your data changes. So, for example, Bitballs, right? If this is an example app that I made, if I create a new player, it will automatically get inserted in the right spot. I don't have to write any code to do that. CanSet just takes care of it because it understands what lists, and it understands the order of a list, and knows to put things in there automatically. This, in my experience, is a extremely common problem when building applications. And it's one thing that CanQuery or CanSet can just solve for you. So this is really why CanQuery exists. And then the final reason why it might exist is just caching, right? If I refresh my page, all of this stuff is, well, if it wasn't being server-side rendered, here it's just rendered from local storage, right? You can see how fast that is. Those fall-through caching, things like that, that's also what CanQuery provides. Okay, so that's why we're working on it, so hard on it, is to provide that kind of caching and real-time behavior. Now, when I originally set out on this, I thought, hey, what we're just going to do is we're just going to have some standard query type, and people will just use that, and everything will be good. But I realized that's not possible. A query type on its own doesn't provide enough information so that you can do the union, intersection, difference stuff that's needed to do the kind of caching and real-time behaviors that CanConnect can do, or that CanSet can currently do, right? If, let's say, we loaded all tasks that were red or something like that, well, if we wanted to look, then someone said, give me all tasks. We don't know if we have all tasks. Maybe we actually have by loading all red. Or maybe we need to know the full set of colors is only red, green, yellow. Maybe we only need to get green and yellow. We don't know that unless we know the top possible values in color. And in order to know that, we really need a schema. We need to know what are the possible values of color. If we see a complete, if we wanted to get all completed to-dos that are true, the same thing, we need to know that true, false, and maybe null are the only possibilities. So because of that, because we need a schema for our queries to actually work, ideally, we don't want people to have to duplicate their schemas. People are pretty much identifying their schemas when they create their types, their to-do type, their define maps. We shouldn't have to have them create a separate schema to pass to their connection. That's essentially what we're doing right now. Like, we require people right now with CanSet create their own algebra. To create their own algebra, which is effectively saying that completed is a Boolean. Sure, we already knew that. ID is the identifier. So what I'm suggesting is that we should be able to, we should basically be telling people to decorate their types such that we know all of that information that CanQuery would be able to use, and to be able to derive a schema for CanQuery. So for example, to do, we could say its ID is the identity property, its type number, complete is a type Boolean, and status is an enum type of new, assigned, and complete. And then essentially what we're going to be able to do is build a query by reading the schema from to do. So it could understand queries like this. And the idea is what I want to be able to do is kind of read a schema from given something, be able to kind of get out the schema. So maybe there's map type schemas, there's enum type schemas, type values, there's single type values. This is essentially the idea. Let me stop there before I keep going into it. Any questions so far? Or thoughts on the rationale?
I mean, it makes sense that, yeah, there is duplicate information there that we've had. Is just to have it in one place makes sense.
Okay.
I mean, it also makes sense to, if there was a way to create a type, or well, I guess there is a way to create a schema outside of define map.
I think there would be a schema format that you could create, but the problem is what you really need are schemas are just essentially like, you know, types, and then can have other types inside of, like other essentially schemas inside of them, which is just the type.
Mm-hmm. What if you're not using define map?
Yeah, so that's where, like, I think we need something like canReflect that can give you the schema no matter what's there. Now, things opt into providing their schema through symbols, likely.
Sure.
So this is very related to the CanCrud style prototyping, and in some ways would satisfy that. So this is where I wanted to be able to create, like, hey, we'd make some custom components that make it super easy to create, like, for a given to-do type, a form that's going to create that to-do type, or list a to-do type, because we would be able to get the schema from them. The original way I wanted to do this was just have canReflect have, like, get own property descriptor, get own key descriptor. The problem with this is that it's really only designed to support schemas for map-like types, key value types. And what I want to be able to do is create types that are not maps, and that wouldn't really naturally fit into that. They might have a you know, more of like an enum takes us to other values, right? This is more like I've got exactly the language to describe this, but, you know, you've all seen, like, you know, types describe like this kind of thing, right? There can be types described like that, like 2 parameters.
So can I ask a question? Why do you want to be able to do that with non-map types?
Okay, so
what's the benefit?
The benefit is, okay, so this is going to get really, I wanted to get further in writing up this issue to, like, explain exactly why. It's because people are going to have those as properties anyways. Like, this enum is effectively one of those types. And we need to be able to do at least certain operations. Whether we need to be able to get the schema off of enum is maybe slightly different than whether we need to be able to do set comparisons on enum. But I guess what I'm going for is more of a unified type system where you can understand how a type is composed, what its pieces are. So, like, an enum is kind of like a list type or something like that. It's got like, you know, different. It's like a set essentially. It's a set type. Okay, we understand what that is. It's in this case, it's all strings. Maybe people could specify that it's all strings, and then you could say like, well, does the number 1 belong in enum? No. If I had another enum of this type of enum that had assigned and complete, can I do a diff of that against something with everything, or do a union with an enum with new? So essentially, what I think I'm going to propose is essentially like you can make types, and types can have symbols on them that enable you to like get their schema, do set logic comparisons on them, are really the 2 most critical components for something supplying what can set when need, and can connect when need. Does that make sense?
Sort of.
Sort of.
Yeah, I think I still need to wrap my head around it.
So let me go like, essentially what I'm kind of, I realize I'm doing is kind of triangulating or coming at this problem from kind of 2 different approaches. Let me start with like the lower level stuff. So like the idea is what we need to be able to do is allow people to just, I'm all over the place. You know, what I want to be able to do is have people say like, yeah, that status or color is green, blue, or whatever. This is going to be the query that they send to like find or get list. What we need to be able to do is say like, okay, well, color is a type, that enum type or whatever, and there'd be values passed to it. What I want to be able to do in the end is like almost do a comparison and do like, maybe I wanted to be able to do so color here, I can get that color from, let's just say this is on my to-do or something. To-do, I could get the to-do, get the schema from the to-do. Let's just say I could get the color property type. That's going to give me this enum. And then I could ask, is green, blue a subset of that, of all options? This is essentially what I want to be able to do. Is ask like, is green and blue a subset of all to-dos, that kind of thing. Or I'd get other information about this.
I don't know how far into this you want to get, but how would it work if you had another parameter that you were passing to get list? Would it?
They need to be combined, right? So there's going to be like an object type or like a set type like there was before, essentially. And this is essentially a set, or like what this would really be kind of considered as an AND operator that works off like key value pairs. And sets can be the same kind of thing. Is I should be able to create a set of this. Now it's going to have some meta information to know that it's kind of coming from color, so it knows that like, or coming from to-do, so it knows that this really represents an enum within the color. But I should be able to create 2 different sets. And then be able to do comparisons with them. And do type, union. And then this would give me a set out.
Okay.
So not only will there be like, in some ways, like a to-do, it's kind of going to be interesting. There's going to be a to-do type, obviously. And then there's also going to be like a to-do set type, which allows you to represent sets of to-dos. And that's what these will effectively be. And this will kind of get created automatically from the schema that we get from to-do. And the nice thing about this, presumably, is you could, presumably, a lot of this stuff is going to happen under the hood. Like, people aren't necessarily going to create to-do sets themselves, although I think they will exist under the hood. It's like a to-do set will be created, and then you can just do something like, get, subset, and then you could have like an array of to-do instances, things that look like to-do instances, and this will like actually just give you those that match this to-do set. Actually, you wouldn't actually do it that way. Sorry, you would just do type union, or sorry, type subset, and you would just say, give me those that are a subset of this. Something like that. You should just use the type operator. I don't know. It's crazy. I'm not really sure where this is going, but like one other thing I want to say is like things like this will get promoted into like a new what do I call it? Real number range inclusive. Well, this would be an exclusive one, but you can imagine if this was greater than or equal to 5, this will get converted from 5 to infinity. Right? And this is a instance of the real number range type. And then you can compare real number range. The idea is that if you did greater than like that, then what you should be able to do is this is greater than equal to 5. And then if you had greater than equal to 4, you could then compare through type is subset. Is greater than or equal to 5 a subset of greater than or equal to 4? Yes, that is true. And then you could do
the opposite.
So greater than or equal to 5 is a subset of 4. Because 4 is included in this set, but not in this set. So this one has everything.
Okay.
It's good. I mean, the math it is get weird, right? Like, but the nice thing about this also is that if you wanted the union, like 2 of these requests were made at the same time, okay, well, we're smart enough to see, and then this will produce essentially this. And you could do union and intersection as well, right? If you said like, okay, or I mean intersection as well. Hey, I want, I don't know really why you would do that intersection as much, but you do union a lot. But it will support all of that.
Okay. I know you're trying not to think about can connect, but how would this? I guess you can't really answer this without knowing how can connect will work. But how would the user use this? Because they're not going to be doing this stuff most of the time, right?
Yeah. So I think what we'll have is a standard like representation like this that is part of the query essentially. But we go through and convert these things. Essentially, what you're going to do is you can provide rules to. So if you see this, essentially this is getting built under the hood.
Yeah. Right. So, but that would be part of a get list or something. That would be a parameter to get list.
Exactly. So, like, you can think of it as like get lists, where let's just say age is greater than or equal to 5. Age is greater than 5, and color is red or something like that. what this is going to be built to is like a new, I'm calling it like, I was just planning on calling it an and for object. It's going to be something like, you could think of it as it's going to be built age, and then age is going to be built into this, and color is going to be built into new, like new. This is going to be essentially the to-do color enum type. Is really what you could think of that is it's a red of that type, and then what you can, and then this is actually, you know, a type itself that represents the set of all things that are age above, you know, 5 and above and color red. And you can do queries against that, age 5 and red, age 5 and red. And then what you should be able to do is queries against that against to-do instances or things that look like to-dos and be like, well, is this to-do a, you know, age 7 color green? Is that a subset? And essentially what this thing's logic will do, its get subset will do, is try to see if the age property here is a subset of this and the color property here is a subset of this. And then I can build ORs as well if I wanted to, logical ORs that do the same thing. So let's see how it looks to actually build one of these things. I'll just do it with enum here, although it's a little bit longer. It's not super cleaned up yet. Right now, this isn't what I think it's going to have to look like in forever. So, did you have a question?
No, well, go ahead. I have a question, but I'll wait for you to finish this.
Okay. So I just can create a normal type, and then I can essentially say how to compare an enum against another enum. And if I want, eventually I can do how do you compare this. This isn't necessarily what it's going to look like. This is just like the first thing that I came up with, an enum against a number. Or I already typecast all primitives in JavaScript to there's a special type.primitive. I can say, here's how if you see a type in a primitive trying to be compared through the set logic of union, difference, subset, intersection, all of those things, here's the methods. Now you'll notice I don't have to provide union, or I don't have to provide subset, superset, equal. Because actually, if you provide just these, you can figure out if it's a subset, a superset, or equal, right? Because what you can do is, like, for instance, if I do the intersection of two things that are equal, well, it gives you the set right back. And then if I flip the order, well, it gives you one equal to both of the others, essentially. You can do, like, there's mathematical ways. I'm not going to go into it right now. There's mathematical ways to figure out everything else from just these three. So for, like, arrays, I essentially, like, do a union of the arrays and return a new enum for the union of the arrays. For intersection, I do an intersection of the arrays and return the intersection arrays. And for I do the difference of arrays and I return that, and then you get everything else for free. And essentially what this is doing is it's registering, like, it's almost like an operator. It's registering, given these types, here's how you do the comparison. The operators, normally with operator overloading, that's actually on the types themselves. But I found that just, like, really annoying to maintain, especially because you want to always have the reverse work. I don't know. It was it didn't make sense to store it on, even though it might be better from a stateful perspective. Essentially, this type thing becomes stateful because it keeps a list of all of the possibilities that are entered. But it makes it kind of easier to know like what pairs haven't been put in this comparison system. So I kind of like it that way right now, at least. Anyways, but that's the idea. You just you create your type how you normally would, and then you just specify like how you can compare it to other types or to itself, which is essentially what it's right here, just comparing, you know, two enum types. I will add it so it can, at least for this one, compare it against primitives, and you know, number range does almost the exact same thing. And I will make that compare to primitives as well. So if you have a number, well, of course, that's a single number is a subset of a range that you were within. Anything else? I know I just took up a lot of time, but I knew this was going to.
Well, I'm trying to understand the project a little bit. Is CanQuery, does it do like all the set stuff, or is CanSet still exist? This is like a higher level API.
This is going to replace CanSet, I think.
So it won't use CanSet. It will. You'll pull everything in that CanSet does into this.
Yeah. Now, I mean, there's going to be a different project probably called CanType. Okay. And it'll be CanQuery that builds on CanType.
So CanType will do all everything you've shown us is CanType.
Yes.
So what will CanQuery do then?
CanQuery is going to be more about like taking these things and building this out of them. Okay. And also gets the given the like given a to-do type, essentially gets the schema, and then is able to like handle this kind of conversion from this kind of what we do want to call the standard query format or whatever. So people don't, you know, I don't want to require people to do this. Mm-hmm. Given the standard query format, builds this for them.
So CanType is the stateful thing, like you were saying. It's going to store all of the ways of finding union and stuff between two types.
Yeah, and it probably might actually move all of the enum, and all of that might move it. It probably moves into CanQuery as well. CanType might literally just be, the only stateful thing is just this map of holding the comparisons.
What decides like how this gets serialized to make the queries? I guess, is that like the REST service?
That would be the service. Yeah, that would be the.
So there'd be, there'd be a standard way to represent this as like a URL as a RESTful service.
Yeah.
Possibly a way for like WebSockets or something else as well.
Yeah. So like the thing is, what you really need for like to make everything work is you need like a type definition. Plus you need like some type of like service description, right? And service description to me means like okay, so if you start with your query, you start with your query, which is like this. Okay. Start with your query, and then what you need is with that query, you need a type definition, which is like, you can think of it as like to do you need your color or whatever to be like an enum. Okay, so we know our type definition. Now what we need is okay, so those two things kind of combine so you can actually kind of query raw data. But the thing is now you need a service description to essentially take this and then convert that to maybe what the server wants, which is like, you know, to-dos age equals, maybe they can support that. And color is, you know, maybe it supports that or something like that. right? You need, maybe they don't put it inside of a where clause or whatever. So that's what the service description does. And then it also handles taking back the data from the server and converting it to the format that CanJS wants. So like that's a very different, right? So that's like a different animal. And then there's can connect, which is essentially putting all of this together.
So back to the can type stateful. So what is going to be responsible for adding those comparisons?
What do you mean by adding the? What do you mean by that? Adding the comparisons.
So like what calls type dot? I don't remember what the API is. Type dot.
These kind of types. Oh, type dot add or whatever the calls these.
Yeah,
things?
compare. Yeah.
Oh, so the types themselves should add that for the most part. So I think this will actually be inside can query. This can query will have an enum type, a real number, just like it does right now. It's just, well, it does. It has this. It has an enum, like what they call prop or whatever, that kind of like mixes in enum behavior into the larger can set. But now this is actually going to be a real type that you could actually use on your own. Like in some ways, that's what I kind of like about this is like if you wanted to do array diffs yourself, like or difference, not a diff, but a difference, like you now have a type that you can actually use to do that, even though this logic was buried inside of can set. But it's like exposed and accessible. I don't know if that makes sense.
So you're saying can query will add all the types that it's using. Is anything else, like, would anything else do that? Would anything else add call type.compare?
Yes, if you wanted to create your own types.
Right. Okay. So user code might do that.
User code might do that. Yeah. So user code could say like, I have, let's say evens for some reason. They wanted to request every other, I don't know, even ID something, right? And then they wanted odd IDs, or maybe there's like time ranges or things like that. This allows you to create your own special ranges. Presumably, can query, there's also going to need to be some kind of like, if you want to like integrate the query language, so like you're gonna have to have some kind of promotion algorithms that's like, okay, well, greater than equal 5, we know that maps to creating this. So you might have to register like, well, if you have an object comparator, right, you can somehow match certain objects and then promote them to things like this, so that then we know how to do the comparison on them. But then it should just integrate so that people could somehow do like, you know, what you really want to be able to do in an ideal world is like do, and then someone could have like, well, I don't know how they would do this exactly, but like maybe they do like, you know, time today. And then they could say like, well, we're going to match time today. And then they could make that a, you know, new date time gets today, and then they can make comparisons and do set logic with today versus, you know, tomorrow, and then they could, you know, combine that could combine. If you do the union of those things, it could become today and tomorrow, or actually use the date object, the user's date object to do that union, and then it turns it into like, you know, February 15th or 16th and 17th.
Cool.
I mean, this is where like people might say like I can see people throwing up their hands and say like, over engineer much. But then I don't know, like, yes, I can see that, but I don't know what the alternative is. If you want the kind of real-time behavior, then we just continue with like what CanSet did. And then, but CanSet, nobody is able, here's what I think. Here's what I guess the one other benefit that I'll say with this is I think that enum here is much easier to comprehend than the and it's also more usable on its own, hopefully, than the old comparators thing. Possibly. My hope. That's my hope, is that it's like I can understand, like, okay, I can easily create a type, set these comparisons, and then to test enum, it just looks like creating enums and seeing if like their subsets or unions are what I expect them to be. Maybe. So yeah, if that's a concern, then bring it up, but let's talk about that. No? Everybody's cool with it?
Sure, it's a concern. It does sound like a lot, but like you said, I don't know what else you would do instead. Not have real time.
Yeah, it just force people to find their list and push things into it themselves where it belongs, which is like the old way we had to do things. My hope is that if we get this right, like this, and part of the reason why I'm trying to keep it all low level, this set logic stuff, is because it's potentially very useful on the server as well. Because the same kind of caching stuff that we do on the client that CanSet enables, a server can do. It'd be very easy to have like your memcache kind of, you see a request coming in and you see data being created. Well, do you need to go to the database every time to fill your memcache with all of the to-dos due today? Or when you ever see a to-do that is in the set of to-dos doing today, you just insert it into your memcache JSON structure and you're done. I don't know if people know what I mean by that, but like that's a super common optimization that people do, is like memcache like certain chunks of data. But the way that I've always had to do it before is like manually request from the database all to-dos due today. And if a new one was created, I either manually like set memcache myself because I knew this to-do was today and I did that check myself and then updated memcache, or I just would have memcache periodically like just re-request the entire database. And this would allow you, if you have a stream of all to-dos being created, to just keep memcache up to date without having to do anything other than just specify the parameters at which set you want to keep up to date.
Is that periodically re-requesting the whole database?
What I'm talking about?
How slow is that? How big of an improvement would this be? Maybe we don't know. I'm sure. Yeah.
I mean, it depends on your if re-requesting your database was so fast. Yeah, I mean, I don't know. It might not be. It depends on your distance and how hard that query is to recreate. If you've got sharded like database of billions of records everywhere, it might be. I don't know. And then the other final thing is the type system. I think it would be helpful for this proposal. I might try to like solve. I'm not going to build these things, but I'm going to probably solve it with this in mind.
It would be nice to have enums in Can-Define also.
I think it would be if we had type validation or type errors and not just type coercion.
Yeah, well, you're right. I don't know. That's something that always like impresses me looking at Elm or Rust or whatever, when they can say like you've missed this case in your switch statement or whatever. But yeah, you have to have the validation on top of just the type.
Yeah, so it would help with validation for sure, but not type coercion. I mean, in some ways, it makes a strong case for like can observe or something. Like its types should probably especially with converters, I think type conversion is, I wish I had just done it type errors. With converters, you don't really need type conversion. You should be converting it to what your model type wants anyways. So the only type conversion that helps, I think, is plain objects into like an instance of something. But all other forms, like, don't convert a string to a number. Throw an error. Okay.
Maybe.
Anyways, I'm going to try to solve it with that in mind because I think that I still really like this. I think it would be good to do this eventually. So I'm going to try to build it with that in mind. Anyways, this is where I'm going. I'm sure there will be more next week on it. And I'll try to keep everybody informed as I do it. Cool. All right. Thanks, everybody, for a good meeting. Until 2 weeks from now, you can do it. Get her done. Steal someone's heart because it's Valentine's Day? I don't know. All right, see ya.